Hello, welcome to our webinar which is broadcast every Thursday at 11 a.m. I am Serhat from Mavi Electronic. Today's topic will be design of gas detection system in closed car parks. Today, with the increase in population density and use of private vehicles in cities, indoor parking lots are becoming more and more common. Indoor parking lots are frequently encountered in projects such as shopping malls, trade centers, residence, fair and congress centers, culture arts and entertainment centers where the human density is high. In such areas, the carbon monoxide gas emitted from the exhaust of the vehicles poses a risk to people in a parking garage. Carbon monoxide is a colorless, odorless, and tasteless toxic gas. When this gas is inhaled, it passes through the lungs and mixes with the blood, and the oxygen level in the person's blood begins to decrease. Symptoms such as headache, nausea, vomiting, fainting are seen in the person. In case of long-term and high concentration exposure to carbon monoxide gas, poisoning and death cases are encountered. In these and similar applications, the measurement of toxic gas produced by vehicles under normal operating conditions and the control of ventilation become a necessity. In addition, the early detection of the effects of a possible vehicle fire and the evacuation of smoke are also very important requirements. We mentioned that carbon monoxide is toxic, but what are its limits? That is, how long we are exposed to a carbon monoxide gas or another toxic gas will cause dangerous consequences. Here, there are two levels. The first of which is the TWA level. The TWA level is the upper limit for 8 hours of exposure to a toxic gas. Another limit is STEL level. STEL is the upper limit for exposure to a toxic gas for 15 minutes. Let's unpack the TWA and STEL levels a bit more. The concentration of carbon monoxide gas in the environment is measured in a ppm units. For example, 50 ppm carbon monoxide means 50 molecules of carbon monoxide gas for every 1 million molecules in the air. The limit values accepted by the World Health Organization for the measurement of carbon monoxide gas are 50 ppm to 300 ppm. It is the TWA level for 50 ppm carbon monoxide gas that is the upper limit that we can expose for 8 hours. 300 ppm is also STEL level for carbon monoxide, which is the upper limit we can be exposed to for 15 minutes. Carbon monoxide gas detection in parking lots is designed, implemented based on these levels determined by World Health Organization. TVA and STEL levels of some gases. If gas detectors have dual level relays and short-term and long-term gas exposure limits are detected, it is critical to activate the ventilation system by operating the relays. In case of such an application, the ventilation system will play an active role in evacuating the carbon monoxide gas in the environment and filling the car park with clean air. These are the project principles according to EN 54 standards. General factors affecting the choice of the detector type, legislative conditions, the material found in the area and the way they burn, the configuration of the space, especially the ceiling height, effects of ventilation and heating, emission conditions inside the examined rooms, possibility of false alarms. For more detailed information, you can see EN 54 standards. These are layout of carbon monoxide gas detectors. Carbon monoxide, in addition to being toxic gas, is also dangerous gas with explosive properties. Its relative density is 0.97, which air is 1. Since carbon monoxide weighs approximately the same as air, the detector should be mounted at height of approximately 150 cm from the ground and approximately 150 cm horizontally from the gas source. If you recall, we talked about 8 hours and 15 minutes exposure limits set by the World Health Organization for carbon dioxide gas. When detecting carbon dioxide gas in closed parking lots, this is done according to two levels. First of all, it's common and practiced acceptance that the car park ventilation system works at level 1, when the amount of carbon dioxide in the environment reaches 50 ppm and works at level 2 when it reaches 200 ppm. It's important that the gas detectors to be used in this application have dual level relays, because it's critical to activate the ventilation system by operating the relays in case of short-term and long-term gas exposure. Limits of these two levels are detected. In case such an application, the ventilation system will play an active role evacuating the carbon monoxide gas in the environment and filling the car park with clean air. While the gas detection and control systems of the indoor parking lots are being designed by the electrical project owners, the ventilation system zone plan designed by the machine project designer should be requested first. Zones of carbon monoxide detectors should be created to coincide with the ventilation zones. Level 1 and Level 2 outputs for each zone from the gas alarm panel, which processes the level information of the detectors, must be connected to multiple motor driving panels for ventilation control. Although the standards accept that the single measurement up to 400 meters square regarding the placement of detectors, the distance between the detectors on these roads can be limited to 10 meters. Since it's often seen that the vehicles are waiting in working condition as a result of the traffic formation, especially on the exit route in the parking garages. It's designed and implementation in a way that does not exceed. In closed car parks where central ventilation system is installed, it's absolutely necessary to manage the ventilation system with a carbon monoxide detection system, especially for life safety, energy efficiency, and long-term use of ventilation devices. For this purpose, the system to be installed should be designed in accordance with electrical and mechanical projects. The installed system should be constantly tested by the users, and the devices should be calibrated at specified periods to ensure that they are operational. Thank you for participating in our webinar. If you have questions, you can feel free to ask me from chat box.